My dear friends, let me first congratulate you all for getting selected in the school hackathon. I think participation in such hackathon itself is rewarding, and therefore whatever results, even if you just participate, that is more than enough. We're just going to talk something little different because we want to have all these philosophy and principles of hackathon to go all your life. Actually, this whole thing starts from being scientific. So I'm going to just talk on 3 different parameters of being scientific. One, how to look things beyond differently, how to look at things differently. Second thing, how the curiosity helps. And then lastly, I will discuss about how to understand science in day-to-day life. Because unless you are scientific, your quality of life will never improve. So let us say how to look at the things differently. Everything happens, but then an intelligent guy looks at it entirely different. I can give several examples. Dornier started their supersonic jets. When the supersonic jet was taking off, a ground engineer observed that the metallic debris on the airport was getting fractured. Now you need to have what is called as a cause-effect relationship. A supersonic jet going on with the ground engineer observing those metallic fractures. He thought, why so? What is the relationship? So he was trying to look beyond, out of box, not correlating with what it is there. And then he reported it to the boss. And then they found out that there are separate waves being created. And these created waves, then they modified, and this is what is called, and gave birth to one of the most non-invasive technique for crushing kidney stones or ureteric stones. And this is what is called as ESWL, extracorporeal shock wave lithotripsy. So I'm trying to give a simple example that looking beyond, looking differently can lead to discoveries. Same thing happens with penicillin, that the mold which was left by accident, the scientists found out that the mold does not permit the bacteria to grow around, and that's why when they removed the substance out of that, the penicillin was discovered. Third example, people or scientists were studying about movement of cells across the electric current. They were using what is called as electrodes which are made up of platinum. And once they were finding out what is the response of these cells with the say microcurrent, they found out that nothing grows around those platinum electrodes. Observation, going beyond, looking, seeing why it is happening. And then they realize that the platinum electrodes, whatever happens, they create one substance, what is called as a cisplatinum. So just looking at this observation, looking beyond differently, led to the biggest discovery of mankind, that cisplatinum is one of the best drugs available for treating cancer. So just I am trying to convince you upon that looking different, looking beyond, say let's become scientific. There is what is called as an out-of-box thinking. That out-of-box thinking is just don't try to correlate everything that is happening. Don't try to network, see beyond. So out-of-box thinking, thinking beyond all these things can lead to being scientific, leading to discoveries. Other thing which helps is curiosity. Everything that happens, we need to have curiosity, because curiosity is not only looking different, but it is looking beyond. Curiosity prepares the brain for learning. It puts brain into a state to retain a new type of information. Anything you ask, if you are curious, you ask more things, and then curiosity makes your brain longer, relating to what is called as processing information for a long time. And once you are curious, you ask questions. If those questions they don't satisfy you, then they go into self-learning mode, and this curiosity prepares you for innovations. A baby is curious. A 2.5-year-old baby asks 26 questions per hour till 3.5 years. Afterwards, the curiosity goes down, the questions asked are less and less. That when a kindergarten baby asks them 6 questions, and subsequently the students may not ask a question for any time. So this curiosity building is very important for being scientific. And I can give you classical example of that T. Smith. She was a primary school student. She was taught about tsunami. She just remembered. She was on a tsunami episode on one of the small islands where everybody was staying in a hotel. And then she saw a 4th grade student. She saw that instead of water coming up towards the end, it was going inside. So this withdrawal of water, she suddenly remembered a geography lecture and geography class teacher that this is tsunami. And they started shouting that this is tsunami, this is tsunami. And then the 4th grade student convinced them that this is tsunami, and then the whole hotel was vacated, and she saved lives of thousands of people. So being curious makes you something which is more important. Now I can give a similar example. I was doing a PhD and I required what is called as centrifuging, what is called as a freezing centrifuge, because my liquid wanted to be centrifuged below 40 degrees temperature. So freezing centrifuge is very costly. So I just went to a lab where they had a freezing centrifuge, and then I realized that nothing, that there was centrifuge and around there was a freeze or freezing mechanism. So I thought, why not do it, because my requirement very low, maybe 10 ml, 5 ml, 15 ml. So I thought, why don't we do same thing in our own freeze? So I asked my boss that, can I put my freeze, can I put my centrifuge in the deeper compartment of freeze and find out whether it works? He said, okay. Then you need to be experimental, you need to be scientific. So we put that whole thing in a freeze, rotated, and found out what is the temperature raised by centrifuge, and it worked. So just putting a centrifuge in a freezer compartment, I was able to find out how we can help. So this is being curious, because this curiosity leads to further things. I think as a school child, I was very curious about everything. I have a small lab or maybe small compartment where I would show everybody how to how to create a carbon dioxide out of ammonium carbonate or sodium bicarbonate. So putting sodium carbonate and hydrochloric acid, the bubbles are created. And then the classical example where people are very curious is about how the water can be sucked. So I was showing a small experiment where there was some small bottle, and then there is a candle, and which is put in water. The moment the candle burns, it utilizes all the oxygen inside the bottle, and the CO2 is created and the water is sucked. So these small experiments then show you how curious it is. I think this is going beyond that. All curiosity leads to innovations, and as a school children, you need to do that. You are more and more curious. That curiosity will help. I can quote another example that how my curiosity explanation helped. I was again in 5th standard, where I was traveling with my father in a train, and then I was in an apartment, and there was number shown. I just asked my father, what is that number? Then he said, this is the number of that cabin, and this cabin might change, cabin might go everywhere, but the number is always constant. And then as a net result, everybody started looking at number, and then we thought we remembered number. Surprisingly, when we climbed down, we just forgot one bag in that same compartment. And then we went to the station master, and because we were curious, I was curious, my father was able to find out that number. Then we gave the number to the station master, and we were able to procure that bag. So being curious all the time can just help you. I think I am just convincing that being curious leads to innovation, being curious leads to all the research. We need to have science in day-to-day life, because the day-to-day life thing helps beyond. There are a lot of things going on in your home itself which are very, very scientific. Let us say example of curd. You all know curd is created by yeast, and you put in the milk and the curd is created. And because that yeast contains lactobacillus, and that lactobacillus, once you eat, it changes the flora of colon, and it is very beneficial. So while we buy a curd from market which is packed, now in order to say sustain that curd for long time, they usually irradiate, and in that process they kill those yeast and they kill that lactobacillus. I think once we once we try to eat that, it is not going to give any benefit because lactobacillus, because the lactobacillus is already dead. So I think being scientific at home, we'll find out that this is the one that is not good. That's why if you want to eat curd, get a curd made out of the yeast or lactobacillus at your home. That will give you a better colonic flora. Other thing, the life of a common Indian woman has changed after pressure cooker. Now pressure cooker is something which is more scientific, science in day-to-day life, that when water is subjected to pressure, it boils at low temperature. So this whole philosophy and principle of a pressure cooker. As a net result, once you increase the pressure, now in the pressure is increased itself by steam. So the pressure cooker itself is one of the biggest discovery, that if you see, if you want to cook without pressure cooker, it might take around 10 to 15 minutes, but in a pressure cooker it will take only 3 or 5 minutes. So this is whole science being used inside. Now suppose you want to find out, now many people they eat tobacco, and then if you see tobacco, they put what you call as chuna or inside and create a quid, and wherever they put quid, they produce ulcer and cancer results from that. Now if you go into the chemistry of this, that calcium hydroxide is what is called as chuna, which is created by putting water in calcium oxide, and is when you put water in the calcium oxide, it's the biggest exothermic reaction. It creates a lot of heat. Actually, suppose you should insist, because nowadays everything is available in market, but then in our days we had an say what you call as a chuna kadi converted into chuna khadi, and then this whole exothermic reaction was seen. Now what happens is, when a man puts say tobacco with this what you call as calcium oxide, there might be some areas of some elements of calcium oxide inside. As a net result, while they eat, it creates an exothermic reaction, and there is a small ulcer, and there is a repeated small ulcer leads to cancer. So, but this whole philosophy is about being science in the day-to-day practice. Everybody has an acidity, and that acidity people take antacids, but then the best antacid, you might have seen, Uno is nothing but a sodium bicarbonate with some multiple of other things to make it palatable, and the moment we have acidity, the sodium bicarbonate goes inside and neutralizes, and that's why you have relief of acidity. The only problem with the sodium bicarbonate or the is that what's called the reflux disease, that after some time you have again acidity. So these are the several examples of looking at science at home. I want all of you to look that whole process inside your home, that how scientific it is, and then maybe look into it, that you become more scientific. Because if you are scientific, then you look at a different angle, you look, then you have new ideas coming, then you do research, then you do innovations, and then you can help the nation. In fact, the Constitution of India, we have rights and duties, and in duties, the Constitution says every citizen of India will be scientific. So I want all of you to be scientific and see that the future of country develops on your scientific attitude. Thank you.